Hi everyone, my name is Enrique Santos and I am pleased to be the co-chair of the 6th Smart City 360 International Convention together with my colleagues Sara and Sergio. Be very welcome. This year we are constrained to a more restricted format, running everything remotely, which by itself is a big challenge for everyone involved, whatever the role: authors, organizers, keynotes, and attendees. However, I am pleased to note that this was not a barrier, at least for the technical and scientific quality dimensions. As you know, this convention is promoted by European Alliance for Innovation, together with some local organizations, this time involving with particular emphasis the municipality and the Polytechnic Institute of Viana do Castelo and the University of the United Nations. The format change made us miss the opportunity to better get to know this beautiful region of Portugal and appreciate the history and local hospitality, besides other wonderful characteristics. But the invitation to visit stays, waiting for better times and opportunities. In any case, and even more this year, the entire EAI team deserves great recognition, together with the local chairs, the conference chairs, and the technical committees, not forgetting all the authors and reviewers that dedicated some of their time for the success and prestige of the event. Together, this exceptional group managed to set up an event of high quality and with excellent contributions in the still emerging area of smart cities. My acknowledged and heartfelt thanks to all of them. As the technology and the experience from new challenge are being investigated and explored, the smart city concept itself has matured. Let me quickly highlight just the following pieces of evidences emerging of new concepts, such as that of intelligent community or intelligent region, and interestingly, this last concept having deserved some reflection in the previous Smart Cities edition. 5C technology, in terms of infrastructure, has opened up new opportunities to further expand the range of applications. Even so, the most adequate technological infrastructure remains under investigation, with no optimal solutions, mainly due to sustainability and maintenance issues. Research in cyber-physical systems, given its impact on the sensing capacity of urban spaces, also present relevant contributions, with some European projects seeking to explore this dimension. Information security and privacy, two fundamental trust management pillars, which in turn are an indisputable foundation in smart cities. It becomes a must for almost all initiatives, and the ephemeral dimensions of mobility, energy, and environment, which, due to a better understanding of the problems, have shown very interesting results. Notwithstanding, governance, public policies, regulation, and standardization continue to make no significant progress despite the recognition of their importance. Even if major developments are not evident in the dimensions mentioned above, there are still significant research and innovation initiatives. There is no space here to list them all, but it still deserves reference, and starting at the European Commission level, the European Innovation Partnership on Smart Cities and Communities, the Smart Cities Information System, or SCIS, a platform for exchanging knowledge, several initiatives and projects in the energy area with emphasis on the city projects of Smart Cities Initiative, which gathers information on all funded projects, now focusing more on worldwide initiatives, the OECD program on smart cities and inclusive growth, emphasizing here an interesting report from the first OECD Roundtable on Smart Cities meeting last July. The United Nations Smart Cities Program, also known as the UEC program, focuses on urban mobility, sustainable housing, clean energy, waste management, and ICT. And many other initiatives of more local scope spread across all continents. With this brief introduction, it was my intention to highlight the importance and the value attributed to this application domain, which crosses several disciplines and knowledge areas. I believe that the future of urban spaces also depends on the quality of what we are going to do here in these 3 days of work. Therefore, I leave my wishes for an excellent and fruitful event, with reinforcement of thanks to all who support us in this year event. See you in cyberspace, and above all, enjoy the Smart City Convention. Thank you very much.
Dear all, I am Sara Paiva, and it is a great pleasure to act as chair of the International Convention on Smart Cities 360 2020 edition, along with my colleagues Henrique Santos and Sergio Savaresi. After the initial presentation from Henrique, I also want to renew my welcome to all of you to this event. I hope to find all of you in good health, as well as your families, in these different times that we live in. But it is in adversity moments that we find new solutions, and for this reason, as a result of a persistent, determined team and with resource to new technologies, this event reaches all of you in a virtual environment this year. Scientific events like this are made to bring researchers together for presentations regarding emergent topics and also to generate insightful discussions that enrich us all. I am positive this convention will deliver all that in a slightly different format this year, but that will still allow us to learn the most recent advances that are being proposed in smart cities. As you all know, this conference is composed of 3 days. The second and third days will be dedicated to parallel sessions of each of the conferences. This first day will be composed of several keynote speeches and also a panel. First, we will welcome the Secretary of State André Azevedo and also Sergio Savaresi from Politecnico de Milano for the opening session of our convention. Next, we will have the first session focused on mobility and transportation that will count on Milos Poliak, Jozef Jandacka, and Anand Nayyar. After a cyber break, we will count on the interventions of Takahiro, Hara, and Okan, Geray that will address the topics of user activity prediction and also circular cities. The afternoon session will be opened by João Santos, a senior expert in the Directorate General for Employment, Social Affairs and Inclusion at the European Commission in Brussels. Next, we will have interventions about Internet of Things 5G and 6G by Henning Schulzried, Mitja Doller and Ana Moreira. After a cyber break, we will have a panel on the topic of artificial intelligence with Predrag Nikolic, Charlie Catlet and Afonso Ferreira. The ending session will be carried out by Henrique Santos and Sergio Savaresi. This year we counted with 10 co-located conferences, and as you might imagine, such an event is only possible with the collaboration of a great team and the joint work. So I address a word of appreciation to the keynote speakers, chairs, the members of technical program committees, to all reviewers, session chairs, and of course to all authors that contributed with their most recent research. I cannot forget to mention the outstanding work of the EAI staff in organizing all the logistics of this virtual conference to make sure everything will be ready for our participants in the best way possible. I leave my wishes of a grand convention to you all here in the cyberspace.
Dear ladies and gentlemen, let me welcome you to EAI SmartCity360 International Convention 2020, held in this virtual interactive setting. I am Karolina Marcinova, and I would like to address all of you on behalf of EAI. As this convention is taking place fully online, I am using this opportunity to address the keynote speakers, the authors, and all the participants on behalf of EAI. European Alliance for Innovation is the largest European-based society that brings under its umbrella researchers from over 150 countries. It was started in collaboration with the European Commission, and it aims to act as a bridge between European research and innovation and the rest of the world. As an annual event, the Smart City Convention is now taking place for the 6th time, starting from Canada, then Slovakia, Finland, and now for the 3rd time in Portugal. With its 10 conferences, its goal is to cover key technology and research in areas that enable development of smart cities. In order to present the topics and provide a strategic view, the convention is complemented by key people from research, industry, business, and regulatory bodies. I would like to thank all of you for being a part of this event and for your involvement with EAI. In particular, I would like to thank the chairs of this convention, Enrique Santos and Sara Paiva, for their hard and excellent work during the past year. Today, during this streaming, we would like to invite you to participate in the Q&A sessions. During each presentation, please write your questions about the current topic into the chat window. After the presentation is done, Sara will ask the selected questions to the keynote speakers in a live conversation. Thank you for your attention and enjoy EAI SmartCity360 International Convention 2020.
Good morning, my name is André Azevedo and I am the first Secretary of State for Digital Transition of Portugal. I would like to greet and congratulate the European Alliance for Innovation for promoting this relevant initiative, Smart Cities 360. Digital transition has been one of the 4 pillars of the 22nd government program, and the challenge could not happen in a more suitable time. On October 26, 2019, this office took place with a focus to deliver a plan to digitally transform our country. A few months later, when the first cases of COVID-19 appeared in Portugal, we had already presented the action plan that would drive this quest for digital transition. But when the work for about 4 months was being unveiled, at the same time we were understanding that the needs addressed were crucial to the survival of our economy in the next months. This digital transition, which previously was seen as inevitable for some, has become a reality for everyone in just a few weeks and months. This constant search for optimization of people's life has led us to the place where we are now in terms of technology. Historically, cities have always been viewed as platforms for civilizational development, and that's the main reason why it is important to have events like this to discuss the importance of smart cities. And the challenge is well known. From a digital transition point of view, currently 3 primary barriers exist that inhibit the widespread deployment of effective, powerful smart city solutions. The first one, inadequate information and knowledge transfer. The second, diverse standards and lack of interoperability. And third, lack of scalability. Regarding the first one, the inadequate information and knowledge transfer, in fact, most smart cities deployments are based on customized systems that cannot exchange information with other intermunicipal communities and therefore are neither extensible nor cost-effective. Diverse standards is the second challenge, for the reason that current architectural standardization efforts have not yet converged. This creates uncertainty among stakeholders. There is lack of consensus on both a common language and smart city architectural principles. The result is that the many groups with smart city interests are likely to generate standards and practices that are divergent, perhaps even contradictory, which would not optimally serve the Portuguese smart city community. And finally, the lack of scalability. This third barrier is the insufficient interoperability and scalability of underlying Internet of Things and cyber-physical systems technologies that provide the foundations for many smart cities applications. Additional barriers include lack of resources, lack of clear principles for prioritization, and limited access to the necessary technical expertise and experience. What is then the solution? To tackle these barriers, the government is working on enabling a widespread deployment of smart city solutions that meet the needs of all municipalities. with the focus of leaving no one behind. The Action Plan for Digital Transition published last April several measures that will offer a new boost for smart city solutions. For example, a national strategy with the vision from smart cities to digital nations. Secondly, a national strategy to create free zones for technology. Namely, we are talking about regulatory sandboxes with the direct involvement of the regulatory bodies. The third one being the transposition of the EU directive on open data and the reuse of public sector information, and also the directive on the framework for the free flow of non-personal data in the EU. Both will level the field for the widespread deployment of effective, powerful smart city solutions. Implementation of an European network of digital innovation hubs. This is also crucial to develop new clusters that will benefit from a smart cities approach. And finally, a digital training program specific for the public administration, namely to progress literacy and digital inclusion, also to improve in terms of skills in the use of productivity tools, also to include the specialized digital skills and methodologies and the reskilling of workers for the ICT area, and finally, advanced training for ICT functions, just to name a few. I challenge everyone to embody this vision of Portugal Digital and to actively participate in moving forward locally so we can, as a country, become a truly digital nation that leaves no one behind. Thank you very much.
Good morning to everybody, and thank you for attending this presentation. My name is Sergio Savaresi. I'm from Politecnico di Milano, and today I will present you a sort of a glance into the future of personal mobility. Let me give a few words about myself and my university. I'm from Politecnico di Milano. Politecnico is the leading university in Italy. It's very high ranked, especially in the engineering and technology area. I'm the founder and the chair of a large group fully focused on system and control in vehicles. So mobility and vehicles is my main research activity. My group is also very active, not only in applied research and development activity, but also in the direct technology transfer. So we have been spin-offing more than 10 startups and new companies in the last few years. Let me now start my presentation with a very general prologue. Let me talk about the so-called mega trends. So which are the main mega trends which are going to affect the future mobility? So the first one is very simple, and it's the let me use the pointer. It's the demographic growth of the population in the world. And so you can see here this impressive picture. You can see that since about 150 years ago, there's been an incredible exponential growth of the population. It's very difficult to foresee the future evolution of the population. What is truth is that today we are able to make planet modification. We can do anthropogenic planet modification. So the second one is urbanization. You can see again the trend. We are going into a deep urbanization of the population, creating congestion from moving cars and parked cars. However, let's say the COVID situation opened a new window. So someone is asking if this unstoppable trend is going to invert and to start decreasing, because the massive usage of, let's say, online working, smart working, can dramatically change this direction, this trend. The third one is aging. You can see here the picture of old age dependency ratio, so ratio of population aged plus 65 plus over the population 2064. You can see Italy, for instance. Italy is one of the oldest population in the world. Today we are at 40%. In 250 we expect more than 70%, which is a huge number. And of course, this is going to affect the type of future mobility, let's call it customers of future mobility. But the most important trend, the most important let's say issue which is affecting let's say the entire world population is greenhouse effect. So in this picture a lot of information is condensed, so just in brief, basically in almost 200 years, let's say the human race has burned fossil fuel and put in atmosphere about 2,000 gigatons of CO2, creating 1 degree more of temperature. We know that we cannot exceed 2 degree temperature. This is really a limit that we can afford. And so the population, the human race, has a sort of residual budget, which is estimated to be 1,500 gigatons of CO2. And it's incredible to see how this residual budget is just a tiny percentage of all the oil we know, and this is where I'm missing the coal and the natural gas and so on. So basically, only a small fraction of oil resources can be burned. So we have to go as soon as possible to a zero CO2 impact way of moving and working and living. So all in all, the mega trends in personal mobility are this. So we are today still in this type of model of mobility. So big and heavy cars, fossil fuel, personal ownership, human driven. And we have to go as soon as possible, estimated time is 20, 30 years, into a new type of mobility model, small and light, electric, shared, autonomous, and of course connected. What is important to highlight is that the automation of the driver will be the real big bang of this revolution, because the automation of the driver will boost the servitization of the mobility, or the sharing of the mobility, and the share of the mobility will boost the size reduction and, most importantly, the electrification. So today we talk about a lot about electrification, but electrification will be, so the second and final wave of electrification will be boosted mostly by the automation of the driver. We will see later a few comments about that. A few words about the electrification. So the electric car today, and this is a misperception, is cheaper with respect to a gasoline, classical gasoline car. You can see here the in Europe, especially in Europe, the figures of the cost of fuel and fuel accumulation per 100 kilometers. Let's say it's 10 for a gasoline ICE car, and it's 7.7 for an electric car. Notice that a significant part is energy, but a major part is about battery consumption equivalent cost. And this is, of course, it's influenced by taxes. So today, most of this cost is due to taxes, but it's valid whatever is the size of the battery. And about this, there is a lot of misperception. The second misperception is about the over lifetime of a battery pack. So today, people are asking more and more range, but notice that there is a hidden drawback, is that the lifetime of a battery pack with about 1,500 cycles, possible cycles, is, let's say, 300,000 kilometers if the range of the car is 200 kilometers. If you double the range, say 400, you get a 600,000 kilometers lifetime, which is a really huge lifetime for a car. So this is why there is this misperception, and increasing too much the range is not the most sound direction that electric cars are going to take. The third point, again, there is a lot of misperception about that, is the recharge time. So there is a general expectation that sooner or later it will be possible to achieve a 3 minutes recharge time like today. But notice that the power which is put into the tank today is equivalent to about 10 megawatt. So it's really impossible for the network structure and network capacity to achieve and to match this type of recharging time. And the final misperception, which is probably the biggest one, is about the real need of range. This picture is very interesting. It has been it's the outcome of a recent research we have done using telematic data. We have analyzed more than 150 millions of trips of Italian cars, and this is the outcome. So, for instance, this is the percentage of vehicle that never do more than 300 kilometers during the year. So let me stress, during an entire year, so it's not an average. So this means that 50% of the Italian cars never do during a day more than 300 kilometers. And if you take away 1 day, 2 days, 3 days, 5 days, if you take out of this counting 5 days per year, the percentage goes up to about 92%, which is really a huge number. So all in all, there is a really big misperception of the real need of range, of autonomy for a car. And something in this neighborhood probably is the right compromise between cost, weight, lifetime of the battery pack, and the real need of an electric car. A few quick remarks. Of course, we know that, let's say, from the CO2 impact, going electric is not enough. So, for instance, in France, electricity is produced with 50 grams per kilowatt hour. In Estonia, it's more than 1,000. So it really depends on how we produce electricity. Lithium is going to be a raw material which is going to influence the new equilibria. Is a very critical raw material, and is very much concentrated in South America. So it's incredible to see that about 50% of the easily exploitable resources are in Bolivia. And for the manufacturing of electric motor based on permanent magnets, we need rare earth, and again, China is a monopolist about that. So I mean, this is about the distribution of natural resources which are needed to go electric. The second, let's say, topic I would like to briefly discuss with you is the self-driving car or the autonomous car. As I told you before, this is the real big bang of the revolution in the mobility. Where are we today? So today we are on the edge between the level 2 autonomous car and the level 3. Notice that the level 3 is similar to the autopilot of an airplane. So it's like this is the image of level 3. So basically you can disengage and you are authorized, you can legally disengage and do something else, like reading a newspaper or whatever you like. Notice that from the technological point of view, L2 and L3 are very, very similar, but the real quantum leap is about the liability, because in level 3, the liability, the responsibility is handed over from the driver to the car manufacturer or to the autonomous system manufacturer. So this is something which is going to take some time because it's a real legal quantum leap. What is going to happen in, let's say, with the automatization of the driver? This is what we expect in, let's say, 15, 20 years. So starting from today's situation where most of the cars are, let's say, all purpose, let's say function and fun, are private object, a bit of function, a bit of fun, in a clear bifurcation with a small niche of emotional cars. It's really a niche, just really emotional cars. But the largest majority of the car will be made by let's say, A to B, from A to B shared robot cars or robo-taxi. So this is going to be the largest majority of the car. With this model, we will see a major reduction in volumes. How much, again, real data can tell us how much is the expected reduction of the number of cars. You can see here, this is a real data plot. This is the number, the percentage of simultaneously used cars in Italy. And you can see that with 10% of the cars available today in a fully shared autonomous robotaxi model, with 10% of the car, we can perfectly fulfill the need of mobility. Of course, we expect, so if the way people are going to use the cars does not change, a 10 times increase of the average mileage. So basically, we expect few cars, very highly technology equipped, with a model very similar to those of the taxi. The big question is now, we can expect a 10-to-1 reduction in number of cars, but the question is going to happen even more? So this is the intensity of the cars in Los Angeles area before COVID and during COVID. So we have been talking about the mega trends of physical personal mobility, but let me remind you that the 30 years from 1990 to 2020 will be probably remembered as the digital convergence 30 years. So all these objects has been converging into this, let's say, personal mobile device. The next 20 years, we will probably be remembered as the digital mobility convergence 20 years. So mobility as a service, autonomous cars, augmented reality, virtual reality, mixed reality, smart glasses, and whatever you like. So it's a mix of physical and virtual mobility. So we are going very quickly in the virtual way. And let's say the way I'm talking to you, I'm not physically in a conference room, I'm talking with the e-conference method. It's a clear, it tells us the direction we are going. So this is the evolution or the escalation of the mobility. So this is 30, 40 years ago. This is yesterday, this is today, and this is tomorrow. Because ICT technologies are evolving much faster than vehicle and transport. There are no safety issues. There are no major infrastructure investment or a much smaller infrastructure investment. So a near future with limited personal mobility is probably going to happen. Let me show you some recent data. This is the question, have you purchased groceries online, which is a sort of ultimate way of doing online e-commerce. You can see the trend was already clear, but COVID created a major boost, a major acceleration in this trend. So it's basically an acceleration of a trend which was already happening. If this is the trend, what is going to happen is that what is becoming more and more important is goods delivery, parcels delivery. So this is the expectation in 2020, but this number should be updated with higher numbers. 80% are light parcels, 50% of delivery cost is last mile delivery. So we are going into two different directions. From one side, we see the Uberization, so mobility as a service. This is sort of symbol or icon of this robo-taxi autonomous car model. But on the other side, we can also see a major trend, which is goods mobility. We can call it the Amazonization of the mobility. Couple of videos. This is a visionary video from Continental Corporation. You see the mini electric bus bringing some robo-dogs, male dogs that deliver the package, or a bit less a bit more down to earth. This is a recent video, recent project from Polytechnic Milano. This is a spin-off. It's a EAI project. It's a sort of fully autonomous Pony Express for last mile delivery, indoor or in a urban environment. So this is the direction we are going to take. So timeline. So I told you that today, if there are 100 cars today, we expect going down to 10 with a massive introduction of robotaxi mobility model, but we increase virtualization of mobility, we can go down to 9, 8, 7, 6, 5, and we don't exactly know how small this number can become. And these two phenomena are working in parallel. So about the automation of the driver, there are some estimation, there are some forecast. This is a recent McKinsey estimation that tells that in 2035, the number of level 3 autonomy or more can be from 10 to 95 range of the cars, which means it's really difficult to predict because most of this range depend on regulatory issues and liability issues. I like to highlight this, which is a sort of dilemma of governments today, of policymakers today. So this is a comparison between introducing immediately today the autonomous vehicles, even though they are not fully safe, or to wait a lot, to wait other 15 years until they are almost perfect, and the balance between the fatalities, this is an estimation in the US, between this strategy that looks very aggressive and very unsafe, and this, which look much more safe, is a loss of, sorry, it's a wrong zero, 400,000 people saved if you would take this much more aggressive policy. So this is an example where the best for the single, which is, let me say, this today, if you look at the single fatality, is against the best for all. This is a big dilemma that policymakers will have in the next 10 to 20 years. So let me conclude by with a bit provocatory conclusion. So which are the survivors of the physical mobility on the 10 to 30 years horizon? So the first one for sure is the robotaxi. So dramatic reduction of the number of vehicles, possibly very weak market segmentation. There is debate on this issue. And of course, few manufacturer, high-tech robotization, automation, and technology. This is going to be the important technology for this type of car. Small niche, leisure vehicles, the red cars, the emotional cars, leisure vehicles, probably confined to circuits if autonomous mode will be not available for them. Very important, soft mobility. Soft mobility is one of the most rapidly increasing types of mobility, so e-bikes, bikes, scooters, e-scooters, and so on. This is a huge trend. Commercial vehicles, we have seen that the Amazonization of mobility will boost a lot the goods transportation part of the mobility. So from the long haul transportation, small metropolitan trucks, and the dronization of the last mile. And the last but not least is not strictly related to mobility, but they are still vehicles. So we need food anyway in any type of mobility. And so there is an unstoppable trend of the automatization of the agricultural machines for both extensive crops and for intensive agriculture. So the dronization is a very important trend also in this field to achieve maximum efficiency, minimum energy consumption, water consumption, and so on and so forth. Okay, thank you for your attention. And if you have any question, I will be happy to try to answer to your question. Thank you very much.
Ladies and gentlemen, I am pleased that despite the extraordinary situation that now persists in the world connected with the COVID-19 disease, it was possible to organize the international EAI Smart City 360 conference online. It is a great honor for me to be able to speak at this important conference. Let me greet you all from Slovakia, from the University of Žilina. I would like to share with you the result of research on the sustainability of the transport system. I share my presentation. My research at our university focused on economics and transport law. Therefore, I will not focus on the technical sustainability of the transport system, but on its sustainability from the view of drivers' remuneration, their fluctuation between transport companies and also within the common market of European Union. Why is it necessary to pay attention to the sustainability of the transport system from every point of view? Transport and logistics significantly affect the economy of each region. In the European Union, we have an experience that only those regions that are connected by high quality transport infrastructure are economically growing. Without appropriate infrastructure, there is not investment, which leads to economic stagnation or even declining in the region. According to statistics, transport and logistics account for about 11% of the gross domestic product in the EU. However, the operation of the system not depends only on technical means and optimization. Of course, these are significant factors. However, autonomous trucks are not yet a reality, so we cannot forget. Without drivers, the system cannot work today. Therefore, in the next part, I will focus on drivers, evaluation of the system sustainability through drivers and their remuneration. Nowadays, the European Union works as a single common market. There is not only the free movement of people, but also the free movement of goods and capital. The Visegrad 4 countries, Slovakia, Poland, Hungary, and the Czech Republic, entered such a market in 2004. The operation in the common market, they had to meet many conditions, but the expansion of the market has significantly helped the road transport sector. Today, carriers can transport goods within the EU without special transport permits. Strong competition is a special feature of the EU transport market. There are many carriers on the market who are trying to remain on it. This is an unhealthy situation because the development of a transport price doesn't correspond to an increase in costs. At our university, I have been processing cost indexing for the Careers Association since 2009. Here, I have prepared a picture showing the price development for the same transport route realized by vehicle combination with a total weight of 40 tons. From 2004 to 2017, price increased from 0.74 to 1.15 euros per kilometer. Until 2020, price remained at the same level, approximately 1.15 euros per kilometer. On the other side, the costs have risen significantly. During this period, individual states introduced tolling systems. That means the performance road toll. Germany, Austria, the Czech Republic, Slovakia, Poland, and Hungary gradually introduced tolls. It means all countries through which carriers from Central Europe drive. For example, in Slovakia, the costs increased from 950 euros per year for a one-year vignette to 0.25 euros per kilometer with 100,000 kilometers per year and only 50% portion of the toll roads. This is a jump to 12,500 euros per year. Wage costs and fuel costs also increased. The costs increased with minimal price growing lead to competitive pressure on the market. Carriers from Western Europe understood that toll, fuel, and also vehicle price are the same for all. However, the wage that also enters in a price is different. In 2020, the minimum wage in the Visegrad 4 countries ranges from 487 euros in Hungary to 611 euros in Poland. In Western Europe, the minimum wage is significantly higher. It's ranges from 2,142 euros per month in Luxembourg to 1,108 euros per month in Spain. It is, of course, the motivation to employ the drivers from Eastern Europe by companies in Western Europe if there is the lack of drivers. However, they had to comply with the minimum wage applicable in the country where the company has its registered office. On the other hand, companies from Eastern Europe do not have enough drivers, so they have to pay a reasonable wage to keep them. At our university, I have been working on this problem for a long time. In 2017 and 2018, we carried out extensive research to find out the real income of drivers in each country. We contacted the drivers directly in the trucks parks, where we identified the state of the employer's registered office and the wage value in the questionnaire. We were able to identify carriers from the following countries: Belgium, Denmark, Luxembourg, the Netherlands, the Czech Republic, Norway, Poland, Austria, Italy, and Slovakia. We found that the average wage in Slovakia was lower than in other countries. However, we were not satisfied with the results because the selection of drivers in the truck parks took place in Slovakia, which significantly influenced the scope of carriers from other countries. We only had data about foreign carriers only from drivers who drove through Slovakia at the time of the research. Therefore, we focused on statistics. We have not been able to obtain data for all members countries of the EU. We processed all available data on wage paid in 4 Central European countries, namely Slovakia, the Czech Republic, Poland, and Hungary, and in 4 Western European countries: Austria, Belgium, Germany, and France. In total, we processed information on the remuneration of drivers for 126,600 transport companies for the period from 2014 to 2018. I know that these data were for all transport companies in these countries. This figure shows the average hourly wage of drivers for 2018 in analyzed countries. There are significant differences between countries. It is possible to make 2 groups of countries. The first group of countries reach an hourly wage ranking from 49.8 euro to 43.9 euro. These countries are Austria, Belgium, Germany, and France. The second group of countries includes the Czech Republic, Slovakia, Hungary, and Poland. Their hourly wage is from 13.11 euro to 9.17 euro. This is a significant difference. In the first group, the rate is almost 4 times higher. It is clear that carriers from the Eastern paid of the EU can make the same transport within the EU and the same price. They can have a higher profit because they have lower wage costs. We also examined the development of hourly wage in the Visegrad 4 countries. Based on the growth of hourly rates, we can say that it will take a very long time for wages in these countries to catch up with rates in Western Europe. We also deal with the jump in Poland between 2015 and 2016. It is a matter of adjusting the statistics of counting contribution to insurance companies. Since 2016, the data are correct. It is clear that in a sufficiently long time, the market will resolve this difference. However, another factor arises here, the use of the difference between the minimum and the average wage as an advantage. There are transport companies in Western Europe that establish their fictions headquarters in Central Europe country, for example in Slovakia. It is a Slovak company, but it has a real office, drivers, vehicles, service workshop abroad. For example, in Slovakia, research revealed that up to 26 transport companies are at one address, and it was a residential house. It is similar in other cases where there are 19, 17 or 11 transport companies at one address. The company may have a rent space of 1 square meter. There is no place where the truck would park. We can say that the company headquarters is a mailbox where the carrier receives official mails from public authorities. Customers send documents to the office. During the research, we found that in Slovakia, enterprise from Belgium found it up to 58% of these companies, and from Germany 27% of them. There is also a small share of companies founded from Luxembourg, the Netherlands, and Ireland. Slovakia is not unequal. The same companies exist in Hungary, Poland, Bulgaria, and so on. What is the purpose of setting up letterbox companies for carriers? It is a matter of circumventing the rules in force in the state where the carriers is established. The company doesn't have to comply with the minimum wage valid in this state. The carrier concludes the employment contract according to the regulation of the fictions seat. In this case, the company also simplified the recruitment of drivers in the country of the false establishment. Such companies distort the market even more significantly as they gain a competitive advantage in being able to pay driver lower wage and still often do not pay various taxes. For example, the value of a motor vehicle tax is also according to a place of vehicle registration. The carrier pays it only if the vehicle appears in the country of registration at least one during the year. For example, if the carrier has a vehicle registered in Slovakia and they are the whole year abroad, the carrier does not pay the tax in Slovakia, and he does not pay in another state. The reaction of the countries of Western Europe is not correct. It distorts the common market even more. For example, in 2015, Germany introduced the MILOC, the minimum wage law. With this law, Germany tried to enforce the minimum wage for all drivers who drove to Germany or from Germany. From 1st January 2020, the minimum rate is 9.35 euros per hour. Based on the analysis, we brought that the average wage in the Visegrad 4 countries was already around 11 euros per hour in 2018, so they met the minimum wage condition. However, the protective measurement is that all statements must be written in German. It is not possible to use the national language or English. Sanction as shown in the figure up 500,000 euros are significantly disproportionate. Other countries take similar protection measures. France, for example, required not only all documents in French, but also a delegate in France who will be able to communicate with the French authorities in French. It is an essential tool for protecting their market. Of course, market protection also takes other forms. For example, the European Court of Justice ruling the France and Germany had detected correctly in finning drivers who took regular weekly rest in the vehicle. The ban on taking rests in the vehicle is worth considering. The driver has privacy and comfort in the vehicle. Bed, internet, TV, refrigerator. Now, the drivers have to go to hotels, often 4 in one room with shared toilets in the hallway. The vehicle with the goods must be parked in the guarded truck park, especially if there is an expensive consignment in the vehicle. All these measures increase costs of the carriers, costs of insurance, the hotel, and the parking. They do not contribute to the greater driver comfort. The European Union is a good project if it works on the principle on which it was built. We must ensure that everyone has access to the market on the same condition. On the other hand, we cannot distort the market with national protection measure. Otherwise, the system will not be functional and sustainable. The European Union has begun to address some of these issues through a mobility package. Significant measures will come into the force from 2022. However, we still have not solved the system of education of new drivers. transportation is provided mainly by drivers over the age of 50. The driver professions is not attractive to young people. Here is our challenge to sustainability of the system. We found out why we do not have young drivers in one research. The answers were surprised. We have many smart areas. We have smart mobiles, smart tachographs, smart cities, but we do not have smart truck parks. I don't mean the gooding to car parks with such a thing. I mean, for example, a tachograph that would not just control the driver. It would be able to find a free parking place to rest or reserve it at a specific time. Today, we have a smart tachograph that remotely controls the driver. For example, the police officer can check for speeding without stopping the vehicle. But what smart does the tachograph offer to the driver? It is all the more surprising when we look at water bottleless drivers. Truck parks with inadequate equipment, without clean toilets or showers, are a problem for drivers. There are now opportunities for eating the driver's social activities. Tax parks usually do not ensure the appropriate protection of drivers and transported goods. Drivers expect that a smart solution will enhance all these areas. Ladies and gentlemen, the field of road transport is extensive. I have only outlined some of these issues, but I hope that my speech will help solve them. Many thanks to the organizers for opportunity to speak at this conference and participants for their attention. Thank you very much.
Dear and distinguished colleagues, first of all, thank you very much for the invitation for the keynote speech. I would like to introduce to you our University of Žilina in Slovakia, topic Smart City, and our view from the point of view of the Middle European cities, and to focus on transport services sustainability tool as we see on it. The University of Žilina is a university with 67 years of history, where we also focus on one of the topic, which is the smart city for the future, with focus also on safety between building of smart city. Regarding the introduction and our motivation, I would like to start with ambitious of the cities with implementing the smart solution, where nowadays in many cities and in their development strategies, we can see smart approaches implemented in order to transform cities into so-called smart cities. Our research implies less focus given to the field of safety, but still many of these municipalities implement solutions of safe city concepts as well to reach resilience. However, it is needed to understand the city as a complex environment, their smart and safe concepts as interconnected parts, and we see also the need of complex understanding of a smart city concept for enhancing resilience, and especially between the transportation. Another point for our research is the lack of importance given to the safety, as I mentioned before, structure and relationships of smart city concept, which I will introduce in a minute, and definitions of parts of the structure. And also the discussion for our next part of the research, and that's the transport service sustainable tool. I will come back to this picture again, but I would like to point out your attention to the structure and relations between concepts of smart city and safe city, with the focus on transportation and their common systems, and separate the layers, as you can see, and I will discuss in a minute. A smart city, it is a vital goal of all modern cities. Today in the world, there are already many cities successfully reaching the smartness in some fields. In Slovak Republic, we have some cities such as the capital Bratislava, Košice, Poprad, and also we are glad to count our city of Žilina, as well as other cities such as Nitra and so on. They are advancing in reaching this goal as well, but a common understanding of what does it mean to be a smart city, what are the systems and features, it is still not defined between the strategic documents. Also, there is often lack of importance given to the concept of safe city, even though safety is with no doubt important quality of a city, and we can say that in transportation as well, which is our next focus. So our motivation is coming to the different forms of city development, also the negative effects of the progress, need for innovative solution of improvement, focus on sustainable development, also with a focus on transport service sustainable tool, and as well the smart city concept. So what is the goal and what makes the city smart? We need to point out this question to be able to understand this discussion. Next, it is lack of focus given to the topic of safety between the smart city concept, especially and mainly focused in transportation, establishment of systems and parts of smart city concept, clear formulation of basic terms, hierarchization of smart city elements, setting the base ground for further research, last but not least, the transport service sustainability tool as the output we would like to see in the end. If we come to the point of the smart transport system tool, we can see the three main areas of our interest at the University of Žilina. That's the autonomous vehicle, where we cooperate between our university science park with our faculties. Then it is important question of personnel and with the focus on public mass transportation, where we had our main part of the research to be able to see. Now let's have a look on this private mass traffic. This is the draft of the possibility for the view of the combination of advantages, electrical non-emission traffic lines, separate units for 2 people or a person with a luggage, adjustable seating orientation, online reservation for now empty seats, and local centers of operation. And this is making also the base for our transport service sustainability tool as the base ground. So how we can adjust and the adjustability of a service, preference of emission-free vehicles. Next, possible to be clamped together, creating bigger open space. Also, the limited control, availability to the passengers, emergency link to the dispatcher, and so on. So this is the base for creating the transport service sustainability tool. And if we have a look on the research back, then we can have a look on the smart city as the structure of concepts and systems. Slowly I will come back to the picture I provided you in the beginning, but in here you can see, and for a better understanding of the structure, to see the connection between smart city and safe city, and then the structure of concepts and systems. So we have one of the definition of the smart city. This definition we provided 2 years ago between this conference, and we came with a discussion in our section, and it was very nice and fruitful discussion, from which we presented the safe city as the interconnection in between all the concepts and systems between the city. What we brought next was the structure of concepts and systems. So for better understanding of the concept, a structure of relations between the concepts was set up, breaking them into smaller groups. Those groups are systems, layers and features, and components are the individual solutions, the smallest part of the hierarchy. The relationships between components, systems, and layers are illustrated between the huge picture, and in here you can see one cut of this picture with the system of smart transport and its layers. If we have a look on the definition of concepts and layers, then we come to the smart transport system, which is one of the most discussed systems. It affects all citizens and administrative and business bodies within the city, as well by its many impacts such as pollution, street cognition, travel times across the city, and so on. Its importance can also be seen from the fact that inadequate transport systems constrain a city economy and vitality and can cause a loss of valuable space and, in the end, of course, money. Therefore, dealing with transport needs to be tight with the housing and land use policy. It also needs to take into account the density of the city. The most dense points are becoming the centers, where it is the most convenient to gather shops and services, so that no one has to walk or drive a great distance to get what is needed. From this point of view, one may say that smart and sustainable city should be dense. The most important source that help define the smart city were referred to some of the references we used for this conference. Smart transport layers is the part of the smart transportation system that, by the integration of smart technology, planning and construction, increases the effectiveness of transport and movement of citizens and goods in the city and surrounding region in order to reduce transport times, noise, cost, unnecessary economic charges, and traffic cognition, to minimize air pollution and to allow simple access to any public area through the city, even to the people with special needs. As well as the other systems of safe city, smart transport system too partly belongs to the concept of the most important part of the safe city and safe layer. Safe layer of the smart transport system, by the use of technology, planning, construction, traffic rules, and supervision, minimize the amount of various traffic accidents in order to increase the safety of all traffic users and means of transportation and safety and integrity of traffic infrastructure. The layers of the smart transport system should include the following features. And that's what you can see on this picture. Functional layer, so the quality roads and other transport lines, bridges and tunnels, means of transportation, road signs, and relevant data. The safe layer, such as safe parking systems, data monitoring sources from critical parts of infrastructure, tools for prediction of impacts of various crisis phenomena on traffic, and planning of evacuation and backup road traffic rules. The smart layer, of course, is mainly connected to the smart city view. And design and other features such as aesthetic, you can see on the top of all these layers, and interconnection with other systems and centers of data processing. So, with this picture, we will move back to the main structure of concept and systems as the structure and relations between concept, smart city, and safe city, a common system, and separate layers. So, for better understanding of the concept, a structure of relations between the concepts was set up, breaking them into smaller groups. Those groups are systems, layers, and features. Components are the individual solutions, the smallest parts of the hierarchy, and the relationships between components, systems, and layers are illustrated between this main picture of our research. If we come back to the system of smart transport and its layers, then we can come back also to the view on the transport service sustainability tool. And in here, we can see the model for simulation center, from which we can develop also the tool later on. And between these, we choose the traffic components for the preparation of the tool. Why this is important for us? First of all, it is the defining of the concept, where the smart city concept deals with possibilities of components usage between the system. Concept, as this term is used in our work, it is a complex vision about the future conditions from the point of view of specific philosophy, in our cases, philosophy of smartness, of the city, or its safety. Development and implementation of the concept is enacted in individual systems of the concepts of smart city, and for the view of the safe city in our work promoted from the system to a concept. So it ensures protection of society, property, environment, and smart components, their informational, cybernetic, and physical safety. Original system of a safe city is renamed, for example, the smart safety and smart healthcare. Works as an intersection of two concepts, and this is how we can then interconnect all the concepts. Defining of system layers, we said a little bit about it. So there are the three basic aspects: tools, where we had also with our transport service sustainability tool. So what does the system use between this layer? Outputs, what does the system create, or what it does by the use of previously identified tools. Aims, how to output, change the city and the life of citizens, why should we want it, and so on. Define smart and safe layers of the systems, and of course, to summarize the features. In the conclusion, the base ground for understanding tools, actions, and aims of the systems that belongs to both smart and safe concepts was set up. Also, we would like to point out the resilience and the resilient solutions need to merge the philosophies of smart and safe city concepts. Relationships between a clear structure of concept systems, their layer and components must be understood. High resilience between the city needs every system to work with high efficiency and in connection with other systems. Development of technology must be followed by the education of citizens in its use, and also our focus on transport service sustainability tool. Thank you very much for your attention.
Good morning, ladies and gentlemen. I am Dr. Anand Nayyar, and I'm working as professor, researcher, and scientist in Graduate School, Dutan University, Da Nang, Vietnam. I feel highly honored and privileged to be as a keynote speaker for EAI 360 Degree Smart City Conference. Today, as we all know that the world is transforming and every country is focusing towards making their cities into smart cities or mega cities of the future, and there are lots of critical applications associated with smart cities. So today I will be focusing mostly on future transportation system, or I can say the future smart transportation system for smart cities. So let's dive into the lecture. So let us first of all start the lecture with studying the transportation technology timeline when we started with the era of transportation. So you can see that the transportation started from 3500 BC with first wheeled vehicles on carts, and the first wheeled vehicle in history was on the wheel. And after that it transformed to 2000 BC with the use of animals, that is horses. 1662 the revolution came when Blaise Pascal invented the first public service for public bus as a public transportation. In 1790 we used the wheel and we transformed into the modern bicycles. 1820 we have omnibuses, and the first gas engine automobile was started in 1862, followed by cable car invention in 1871 and subway system in 1887. And after that, the taxi cabs, which we can see of today, was started in 1897, and 1908 found the better car production using Henry Ford, and we have come today in 2020 when we have autonomous vehicles and even fully autonomous flying cars. So today we see transformations in the mobility space mainly into two sectors. One is gas powered, that is electric, and today is human driven, that is now known as autonomous. So you can say gas driven vehicles are transforming to electric vehicles and human powered vehicles are coming to autonomous. And you can see from the slide that all it is taking a different forms in terms of autonomous cars, small quadcopters, drones, autonomous robotics that can do delivery, and even the smart electric and autonomous trucks. So autonomous vehicles have the will to change the world in three broad sectors, that is customer experience with saving lives and money, broader disruption with reshaping the entire industries, and business opportunities because it can become a multi-trillion-dollar market in the near future. So auto industry is going to change the future, and it is going to revolutionize in the next 7 years with three broad parameters. One is technological, that is autonomous driving, electrification and connectivity. Then we have social with urbanization, sharing, and regulatory with city regulation and emissions and emission standards. Intel is one of the best companies that you can see. It is leading to the road of autonomous driving with three major parameters: self-driving, system functionality, and safe driving. They started with the electromechanical safety with providing airbags, electronic stability with in-vehicle infotainment, and after that then we have information to the drivers for blind spot and assistance. But after that, these last two technologies is going to revolutionize with adaptive cruise control, emergency braking, and self-driving. Automated driving technology progression, you can see that it is changing by leaps and bounds. We started in 2015 when we have adaptive cruise automatic braking, that is level 1. Then we have 2017 with supervised partial automation. Level 3 we started from 2018, that is conditional automation. Geofenced highly automated driving, you can say automation limited domains, that was started from 2020 onwards, but we can say that we can reach level 5 from 2027 onwards with fully automation. So the road to full automation is leading to lots of things, that is in terms of 4-5 levels. 0 level as no automation, level 1 as driver assistance, partial automation, level 3 by conditional automation, level 4 by high automation, and level 5 by full automation. So these are the 7 main advantages towards individual and society, like fewer accidents, no need to add new car focus capability, less congestion, we have less space for parking needed, we have less car traveled at low occupancy, that is means decrease in pollution, we have lower transportation cost, better service, and above all access to elderly and disabled people. So you can say that in all aspects it is only a revolutionary and remarkable concept to make our cities as mega improvement and autonomous cities. So the question stands in front of us that when we can see the autonomous vehicles. So as per the latest report by statistical analysis, we can say that 34% of US citizens have seen that 6 to 10 years will see improvement and adoption, and 34% is a good percentage according to me that can see that in next 6 to 10 years we will drive autonomous and flying vehicles. So now we will discuss the imaging, sensors and systems technology. So you can say that in terms of imaging technology for automotive, like we can see that drivers are using their cars eyes for driving. You can see that we have the different types of imaging technologies in terms of short range radar, long range radar, visible cameras for rear parking assistance, accident, and you can say mirrorless cars can also use for traffic sign recognition. 3D cameras for gesture recognitions, night vision cameras, LiDAR for 3D mapping, ultrasound for parking, and dent reckoning sensors for odometry. So lots of things are happening in this imaging technologies. So you can say the sensor technology most important, and you can see lots of sensors will be surrounding the car at the front, at the side, and at the rear. So at the front we will have parking assistance, traffic sign recognition, adaptive cruise control. Similarly, we have the parking assistance as well as surround view and blind spot detection, and even we will have surround view on left and right side. So autonomous vehicle second generation vision system, which will even contain high-end infrared sensors. You can say that we will have situation level, object level, and feature level based detection. And you can see that we will have host manager, vehicle control, situation assessment, and even we can come towards signal light detection, moving humans in pedestrians, obstacles, road lanes, lots of things. So AV specific redundant hardware system, you can see that we have 14x cameras for traffic lights, 5x lidars, 3x radars for unprotected turns, 8x radars for detecting vehicles and velocities, 10x ultra short range radars. So the radar and the lidar market, it is progressing by leaps and bounds, and you can expect that by 2027 the lidar market only can touch $4.4 billion US. So these are lots of good players in the market, and you can say that as per the flash radar, Continental, as per MEMS radar, we have Pioneer, and as per optical phase array, we have Quan Energy. These companies are doing wonderfully well. And in terms of radar's long range evolution, you can see level 1 started in 2014, followed by object detection advanced features in 2016. We have 2018 with high resolution, and 3D detection was possible in this year in 2020 with the level 4 based improvement, and level 5 it requires 10 years for 360-degree object recognition. So these you can see the applications of MEMS in automobiles with inertial sensors, pressure sensor, infrared, RF sensors, and we can see sensors all around the car. So 2017 to 2013, we can see the future forecast of sensors in the market, and you can see that the sensor technology can reach up to $20.4 billion industry by 2023. So automotive MEMS and sensors, you can see that Bosch company is #1 company for this. And for vehicle automation process, you can see communicate, sense, localize, think, act, and supervise. So everything will be connected together. So in terms of autonomous vehicles, we are developing the MVP, and all these components need to be developed for a successful vehicle. Self-driving brain, deep simulation capability, HD routing, cyber security, proprietary AV sensors, total cost optimization. So this is the self-driving software brain, everyone, that you can see that it requires ecosystem of technologies, tons of technologies. Even the mankind that has invested till date is required to make up this type of car. So lots of leaders are there. You can see that with GM, contenders are there like Intel, FGCA, Toyota, Baidu, Navia, Volvo, and challengers are there like Apple, Tesla, and Voyage. So all these companies are merged together, and they're adapting the technology for autonomous vehicles. So now let us talk of connected vehicles, big data, content, and data marketplaces. So the most important bottom line for the autonomous cars to operate in the world is the cloud computing, because everything will be cloud, and we require 6G or 5G connectivity for the exchange of information. So you can say the cyber security is one of the most important thing. So that can be protected not only with IDS or firewall, it requires blockchain technology. So these are the connected car services that you can see that will be available in connected car services, like live agent assistance, like an AI voice that we have seen in lots of sci-fi movies, vehicle monitoring and controls, location controls, communication, and infotainment apps. So this is the major eye-opening session for you. You can see that one autonomous vehicle per day requires 4,000 gigabytes of data. And you can see that it is not a joke, because it requires lots of sensors that are integrated, and they are working autonomously to make the car to operate. So this is the intersection of analytics, connectivity, and mobility. and the cloud will lead to more edgiest edge computing. You can see with cloudy edge, the level 1, level 2 with business edge when we have cyber physical systems with 6G or 7G, and with the edgiest when we can even expect 10G to hit in the market maybe after 15-16 years. So autonomous vehicles have potential big data solutions, you can see, with edge computing, AI technology, and radio access technology. And this is the connected car landscape that you can see lots of companies are working, and we expect that in the near future almost every IT company that you can think on this planet will be working for this project. So now we talk of wireless connectivity and communications. So you can say the primary connectivity that we require for vehicle is 5G, and the most important standard is IEEE 802.11p, that is known as vehicle to X, which means vehicle to anything connectivity. And automotive DSRC, that is dedicated short range communications technology, is improving, and you can see in 2020 we will have vehicle to grid, vehicle to infrastructure, vehicle to device, anything that you can think of. So the cellular technology needs to be improvised because the car is driving and everything requires to be connected. So we require minimum 5G connectivity for that. And we are talking of advanced LTE protocols like ubiquitous LTE, gigabit LTE, 5G NR sub 6 gigahertz, and we require 5G NR MM wave. So which means that minimum speed that is required for the connectivity for the cars to operate will be minimum 10 to 15 Gbps. So 5G has massive use cases in terms of IoT, broadband, and critical applications. And this you can see with the multi-path of IoT connectivity. We have come from PAN, LAN, MAN, WAN, and even we can say that we can get the Earth area network. So in the future, I am also working with my team on this technology. We are working on LoRaWAN. Recently, we have done the patent. So we have Sigfox, LoRa, and on-ramp. These technologies will be regarded as a communication standard for operating IoT technologies. So now let's start with examples. You can see Google X building hundreds of cars with no steering vehicles. It is even seen in the movie that is Internship. Uber, again with the flying taxis. Tesla, you can see the model right now, the Model 3 structure, autonomous vehicle. We have the Volvo 320C concept car. We have the Charge Electric Vehicle magazine that is claiming that by until 2025, we have the 50 plus new BEVs. And Volkswagen is unveiling self-driving electric microbuses, AV robotics modular vehicle system, and we have EDIT, that is bring your own self-driving code and custom hardware stack. So the future is very bright, and this is what we can see in the near future. I am expecting this to hit the market by 2023. Toyota Mobility Services vision for parcel, e-commerce, airports, local things, many things. So you can see that Tesla, Audi, Toyota, Volvo, Nissan, Honda, Mercedes, Ford, all the automobile giants are working on fully autonomous vehicles. So this is the near future, everybody, that you can see the Postmates will be coming to your home to deliver you the parcels, the food, and everything. And you can see FedEx with the future autonomous delivery robot. And this is the Sea Hunter autonomous ship. You can see that it was going to land for military. And this is the PAVs flying car. Now a sci-fi movie is now a reality, and you can see it can comfortably hold 2 passengers, and it can operate as a car and an aircraft. And this is the flying car by Moller, and you can see that it is making the sci-fi dreams reality. Volvo's Volcopter, that is in Germany, again a groundbreaking invention. Skydriver Scuba, again a sports utility aircraft vehicle. And the question stands, are you ready to fly without a human pilot? So this was my vision 10 years back, that after 2020, mostly the people will become a pilot, and flying cars is not a new example for all of us. Every country is investing and investing. And this is going to be the first aircraft, Zunum Arrow, to carry a passenger jet and fly without a pilot. And platform for unmanned cargo aircraft, you can see Puka. Hover bike that you can see these days working in Saudi Arabia. Jetpack Aviation, soon it is going to hit the market. And Jetpack Aviation JB10 and JB11, you can see lots of videos on YouTube. It is again a reality, and it is operational in Saudi Arabia and Dubai. And this is NASA Puffin VTOL personal air vehicle concept. So the movie of Back to the Future is now a reality with this Hendo hoverboard. And lots of countries are investing lots of billions of dollars into drones and other survivals. And this you can see a photograph when the complete city will be connected via civil low altitude airspace, when we can see the Star Wars, Star Trek, and all these Bollywood or Hollywood movies becoming reality of flying future saucers. and platform for unmanned cargo aircraft. And this is the AI controlled autonomous vehicles. As you can see in the games like Call of Duty, Black Ops 2, we can see that it will soon become a reality. And this is the aircraft from Russian Combat Aerial System, KUB UAV, having the capacity to fly for 30 minutes and can even carry 6 pounds of explosives. So you can say that aerospace and autonomy center technology areas are safety and security, robotics, enterprise operations, human and autonomy, and above all, intelligent decision and control. So now let us talk of the outlook of the market, and you can see that the robotic vehicle market can even touch $3.5 trillion by 2032. So the forecast of future autonomous shipments, you can see that it is reaching about 569 millions. Or you can say thousands, so I can say, but I expect it could be millions. So you can see from this diagram that the car will not only be the model for only one automobile manufacturer, but it could be the mix of technologies by every company on the planet. So you can see the answers are providing by IT tech giants in terms of supply and manufacture, 3D printing, EV vehicles, parking tech, insurance tech, self-driving vehicles, everything that you can think of. And you can see these are the key change drivers that you can see in the future implications for the industry. And these are the trends that you can see in 2020, like auto e-commerce, flexible assembly lines, industrial robots, blockchain verification, driver monitoring, simulation, fully autonomous vehicles, mobility as a service. It is everything. So autonomous driving technology will advance in waves. That is, in 2030 we expect to have autonomous driving, and by 2035 we expect global megacity networks. So let's wrap up the session now with vehicle to infrastructure resources. And if you really want to be curious about the future mobility, this is the called coalitionforfuturemobility.com based website for that. And soon we will have this type of articles in the near future that you can see, autonomousvehicletech.com, where you can buy your research, your paths, whatever you want to buy. So as per the hypercycle, you can see the number one technology for the world will be mobility as a service, followed by connected car platforms, LiDAR, smart transportation, and above all, it is called blockchain. So cybersecurity will be in the hands of blockchain. So the question is, are you ready for the future? So I can say that yes, I am ready for the future, and this will be the future playground. The ASU Center for Science and Innovation draws futures like Arizona 2045. So thank you so much for inviting me. Now the house is open for questions. Thank you, and soon we will see everything in our hands, and we will drive the flying cars as soon as possible, maximum by 2025. So God bless and take care.
Hello everyone, I'm Takahiro Hara from Osaka University, Japan. It is my big honor to have this opportunity to present our work here in this event. The title of my presentation is Cross-Domain Approaches for User Activity Prediction in Online and Real Worlds. So this is a joint work with Nagoya University and KDDI Research, which is the second largest mobile phone carrier. As you know, in smart cities, various kind of the different services support people's daily life for both online and offline. Since there are so many applications in smart cities, personalization is very important. So services should adaptively change according to user preferences and characteristics. Now I'd like to talk about the problem addressed in this project and our idea. So it is important to provide personalized services by analyzing big service data, such as the service usage log, to provide the users the comfortable services. However, currently there is a strong limitation. It is difficult to share user or persona model constructed in different service providers or domains due to the privacy issue and interest or right issue. So our idea tackle to this problem is to transfer the prediction model between domains without exchanging raw data and user IDs. This figure shows just the image. Before now, there's a kind of wall between each pair of the domains, and they cannot share any raw data ID or user activity prediction model. Here our idea is not removing the walls, but developing some techniques such as persona matching and prediction model transfer to go beyond the wall with the existing wall. In this case, even if some domain doesn't have enough data to model the user activity, it can reuse the good model constructed in different domains. Now I'd like to talk about some example scenarios. First, the web advertisement and e-commerce domain, both online. This is our project case. We may be able to predict the user's purchase pattern activities in the e-commerce domains from web browsing history or web access pattern. The second example is web advertisement and Wi-Fi service domain, online and real-world different domains. This is our ongoing study. We may be able to predict the user's visiting locations in the real world from web browsing history. The last one is Wi-Fi service domain and e-commerce domain. This should be our next step. We may be able to predict the user's purchase activities in the e-commerce site from users' real space activities, such as the visiting locations or movement in the real world. This kind of cross-domain approach is very challenging because we assume completely different domains. As you know, there are so many existing studies on cross-domain approach, but almost all of them assume very similar domains, such as the two different e-commerce sites. But anyway, they assume very similar category services. So our approach is quite different because we assume completely different domains. Now I'd like to introduce some achievement of our research. The first part, we focus on the online and online cross-domain approach. Concretely, we assume the web advertisement and e-commerce domain. Here, our goal is to develop a cross-domain recommendation system. And the motivation is as follows. As you know, the many e-commerce services sell a large number of products in a short time. So this is a kind of flash sales. Many new products appear on the market, but disappear from the market very quickly. In addition, most users have just a few or no experiences of real purchase. So they're just looking or getting some free coupon. In this sense, there are so many new users and new products, they don't have any interaction with each other in terms of the purchase. So it is difficult to model the user's purchase pattern only from the data obtained in the e-commerce domain. In other words, we should address the cold start problem for both new user and new product. So our idea here is to use the cross-domain approach. This is based on the fact that most people frequently view web pages. So our approach here is to utilize rich persona model constructed in web advertisement domain for product recommendation in the e-commerce domain. Here our hypothesis is web browsing patterns give some hint on the purchase pattern in the e-commerce domain. Luckily, we could obtain the real data from these two domains. For web advertisement domain, we could obtain the 1.3 billion web browsing logs from the 2.5 million users, and for e-commerce domain, we could obtain the 15 million product view and purchase data from 0.25 million users. We performed the persona modeling using these data and developed the recommendation system based on the cross-domain approach. Now I'd like to talk about the detail of the proposed model based on the Word2Vec deep learning approach. Here, this system consists of the two steps. The first step is modeling of the user and product. So we generate the user and the product embeddings of vectors from text. Here the interesting thing is we use the different two data sources. For user modeling, we use the web pages obtained in the web advertisement domain, and for product modeling, we use the product description obtained in the e-commerce domain. And we perform word-to-vec that generate the vector from the text to generate the user and the product embeddings. Here the important thing is we don't use any purchase histories to model both the user and product. That's why we can handle the new user and new items and solve the code start problem. And the next step, that step 2, we develop the recommendation model based on the machine learning from the user's purchase histories. Here we first use the purchase history. Of course we need to use them because we need to learn the pattern of the purchase between the user and items. Now I'd like to talk about the performance study result. Here we aim to predict the user reaction to product recommendation. And the concrete task is finding the one product bought by the user among the 1,500 products. So that is the very tough task because we need to find one correct answer from the 1,500 candidates. The comparison method, a cosine similarity based method, and linear model method, and also the random recommendation. The cosine similarity method is the most popular method that are used in the real market. And the performance metric is the ratio that correct product bought by the user appears on the list of top K recommendation. That means the system recommends the K items or product, and if the correct answer is included in the list, that means a hit. And we calculate the hit ratio for each of the comparison methods. So this graph shows the result. The random approach and cosine similarity based approach shows a very bad performance, less than 1% of the hit ratio, even with the 10 product recommendation. Our proposed approach could achieve the 26% accuracy or hit ratio. This is surprisingly high, and 50 times higher than the random approach and 25 times higher than the cosine similarity approach. So this result shows the effectiveness of the cross-domain approach. Now I'd like to move on the next step, the part 2, the cross-domain approach online and real world. And the real world means the location service data. Now I'd like to add new domain, the Wi-Fi service domain, as the real world domain. Currently, we are working on how to model the user in such a real-world domain. And here, the most important things in the persona models constructed in different domains, especially online and real-world, need to be integrated or transformed to perform some cross-domain approach. So one possible idea is modeling users or personas as embeddings or vectors. After that, what we should do is just transforming the vectors between the domains. Now I'd like to talk about our ongoing work to model users from historical data on visiting location. Our approach is quite interesting. Most existing studies on the user modeling in the real world just focusing on the real positions and the transition of the position. But we take into account not only position, but also stay time and number of people for each position. So that means we assign some semantics or meaning to each location. Here, we don't directly model the user, but we first try to model each location and then model the user, and giving some semantics to each location. Concretely, we partition the whole space into the 100 square meter regions and perform word-to-vec approach based on the stay time and number of people. So this graph shows some typical clusters of the location based on the meaning. The cluster 2 represent office areas where the number of people and the stay time increase during daytime, and the cluster 3 represent eating and shop area where the number of people and stay time increase during the nighttime. And cluster 4 shows the residential area where the number of people and stay time increases in the morning and night. So these kind of the informations are very useful to model the location, not just the position, but also the meaning of the location. After giving the meaning to each location, we generated user vectors based on the transition of the location. The typical example include the office workers. These users stay in the residential area in the morning and move to the office area during daytime and come back to the residential area at night. Another example is bar workers. Those people stay in the residential area until noon and move to the eating or shopping area from the evening and come back to the residential area at midnight. So by doing so, we can model the user in more detail than any existing method that focus only on the position and transition trajectory of the users. After modeling the user in the real world, we try to do some cross-domain approach, but actually this year we failed because of the COVID-19. So due to this issue, we couldn't obtain good data for both online and offline or real world. But we didn't give up to continue our research, but rather we changed our mind to do better research in this situation. Now I'd like to talk about our new direction. Here the question is, should we care about COVID-19 for user activity prediction? And this project just started. Concretely, if the user activity significantly change in unusual situations like COVID, the prediction model constructed in usual situations don't work well, and the quality of services degrades for both user and service provider side. So we need to solve this problem. In other words, activity prediction model should adapt to change of the user activity even in emergency and new normal situations. So this is the motivation of our new direction. So as a first step, we have conducted some preliminary analysis on available data of the Wi-Fi and web advertisement domain to examine the impact of COVID-19 on the user activity. This graph shows the user activity change in the real world that are observable from the Wi-Fi provider data. We observed the data from February 1st until the August 2nd. The blue line, the upper left, shows the overall average of the user activity that are based on the count of the user in each access point. So during the first peak of the COVID-19, the user activity in the real world decreased and started recovering. But this kind of change are quite different between the category or the location. The upper right shows the continuous decrease case, very bad case, including the theme park, amusement park like Disney World. The people hesitate to get together in the very crowded area. That's why that kind of activity keep very low. And the minor change, the bottom right case, include the golf course and the mass retailer. Mass retailer is a kind of the big shopping center. The shopping center case is very natural because people have to buy something to live. But the golf course case, I don't know exactly, but the golf player didn't want to change their activity even in the COVID-19 situation. The last case is the recovery case, the first decreasing and recovery. So that includes the public transportation and the zoo and botanical garden. So the zoo and botanic garden case is based on the fact that the people can keep the distance, even if they enjoy the zoo. So these graphs show the activity change in online world. So the overall average, the upper left, shows the activity of the user slightly decreasing during the COVID-19. But it also has strong differences between the category of the online services. Here, we count the web accesses to each category of the contents, and the continuous decrease case include the society contents that are strongly linked to the real-world activity. Society means that some kind of the contents that are focusing on the finding some new partners for dating or marriage, and also the attending the party in the real world. So this kind of the services, the user access is very less because people hesitate to meet some other people. And the minor change case, the bottom right case, include the user hobby, like food and drink and standard fashion. Even in the COVID-19 situation, people keep to search the information that are related to their hobby. The last case is the first decreasing and recovering slightly. That includes the travel. Based on this fact, we can observe the significant change in both the online and real-world services. And the last one shows the change of the user's activity. So the left table shows the transition of the user clusters, and the upper right shows the user clusters before COVID, and the bottom one shows the user cluster after COVID. So the upper shows the user activities are very different between users, and cluster 2 shows the users who are very active in the real world. So the yellow cell shows the typical keywords that represent user activities in the real world, and white one shows the activity in the online. So the cluster 2 shows the very active users in the real world. But after COVID, these users are dispersed into many different clusters because they have to give up some activities in the real world during the COVID situation, and they carefully choose only a few activities. That's why they dispersed into the different clusters after COVID. As shown in this result, the change of the activity is quite complicated, and the user activity have significant change both the online and real world, and pattern is quite difficult to model. In particular, after COVID, the amount of data obtained is not enough. So that's a very challenging research topic. So we will try to solve this problem by applying cross-domain approaches, such as modeling user activity using a variety of data acquired in different domains. So we focus on the cross-domain approach. Now I'd like to summarize my talk. In this talk, we introduced our recent work on the cross-domain approaches for persona modeling and user activity prediction in both online and real-world services. So our future plan include we use the other domains data, and also we try to develop the prediction model that transfer the model from the usual situation to the emergency or new normal situation like COVID. Thank you for listening.
Distinguished guests, ladies and gentlemen, before I start my presentation, I would like to thank the European Alliance for Innovation for inviting me to your esteemed conference. The title of my presentation is Circular Cities, and it's based on the work conducted under the U4SSC initiative, United for Smart Sustainable Cities initiative. So what's United for Smart Sustainable Cities? It's a global platform to advocate policy to achieve the Sustainable Development Goal, SDG 11, which is all about making cities and human settlements inclusive, safe, resilient, and sustainable. The U4SSC initiative is coordinated by three main United Nations agencies. They are the secretariat for it. The first one is ITU, International Telecommunications Union. The second one is United Nations Economic Commission for Europe, UNECE. And the third one is UN Habitat. And it's also supported by other 13 UN agencies. So U4SSC basically undertakes several deliverables. They are called thematic groups. So things like financing smart sustainable city projects, circular cities is one which we will go through today. Others are city science, blockchain, principles for artificial intelligence in cities, and several others. So basically, at the end of the work we conducted, we published a guide to circular cities, which is shown on the screen on the left-hand side. It's basically a high-level implementation framework which is designed to improve circularity in cities and also support stakeholders in implementing circular actions. In addition to that, we have also published 8 other deliverables, which include 17 global case studies about circular action items in different global cities. So essentially, it's a combination of 9 total documents, 1 high-level implementation framework, and 8 case studies across the globe. So if you look at circular cities, essentially they utilize assets and resources more efficiently. They produce and consume more sustainably, and they also apply circular design for large-scale positive impacts. In a nutshell, circular cities either increase the utilization of assets and resources in a city, or at the end of their lifetime, they cycle it back for reusing again. So nothing goes to waste in a circular city. And this applies to a lot of items in a city, including various assets, resources, products, and services as well. So it's a novel concept, and we've seen it in circular economy mostly. But the work that we have conducted extends the basic concept of circular economy to also circular society and circular environment as well. So it takes a broader perspective and builds upon the concept known as circular economy. So what are these opportunities in a city? During the work we did, we started identifying the city assets and products, as we call them. If you look at a city in an urban context in general, there are several components that make up a city. So things like buildings, for example, be it residential, commercial, or public buildings. And then we have public spaces and infrastructure. We also have digital infrastructure in a city. Things like natural resources, human-related and owned resources, all the way from our knowledge and skills to things that we have at home, for example, that we use, that we consume. And then things like private sector assets, warehouses, equipment, machinery, waste in the form of municipal waste, industrial waste, and manufactured goods and services in general are all within an urban context, forming the city assets and products. So when we look at that, it's a wide spectrum of items which are used by cities in different contexts and in different use cases. So a wide spectrum of items. And then if you look at the circular action items that can be applied to them, we have identified 6 main ones during our work. We can share, we can recycle, we can refurbish, we can reuse, we can replace, or we can digitize some of these. So if you look at the matrix overall of these circular action items applied to city assets and products, all of a sudden we have a staggering amount of opportunity for circularity in cities. So each and every cell in this matrix is a potential for cities to apply. So maybe I can give you a couple of examples. If you look at buildings, for example, today once the buildings come to their end of life, we demolish them. And we literally do not make reuse of the building items in general. But imagine a scenario where we can disassemble the buildings instead of just demolishing them, and then use the components in the buildings, different parts and components, in another building down the road. So this would be a circular action item. Waste recycling is something that we all know. Digital infrastructure, our digital equipment, our services can be reused, for example, or they can be shared across entities. So that's another example, taking sharing as a circular action item and digital infrastructure as the city asset and product. Similarly, if we look at items at home, so I'm looking at human-related and owned resources, for example, the items that we at home, we consume every day, some of them are not necessarily consumed very regularly. So things like probably a hammer, for example, you need it every 3 months, once a year. Why not share it across different households? So we can potentially utilize sharing circular action item on some of those household items, so they can be shared across or among the households in general. So these are just some examples. They can be enriched, enhanced, because as you see, the potential is staggering when it comes to cities in general. So taking this, we then established a 4-step high-level implementation framework. Now that we know the potential, the first thing that we can do is we can assess the current circularity in cities. In other words, we can create a baseline of where we are in the cities to understand the current scenario for circularity. Once we know the current scenario, then we can prioritize and determine the future circularity. So what are some of those potentials that we have seen which can be applied to cities? That would be in the second step. And then once we decide what to do in the cities, the next one would be to catalyze them or to boost them. Can we do certain things to accelerate the implementation, to make them more efficient, more effective in terms of applying these circularity action items? And then finally, we reach the 4th stage where we assess what we have done essentially and see the circularity impact. So it's almost like a circular, again, a loop. We start by assessing, then determining what we want to do, followed by catalyzing or boosting those action items, and then assessing where we reached, and then feeding back again to the first step. So that was the high-level implementation framework. I'm going to probably go through a couple of examples on the steps here. If you look at the second one, for example, assuming that we know where we are, what we have done so far, we can prioritize all these potentials that I was mentioning in the matrix in a simple manner by using 2 axes. One is the value, the vertical one, and the second one is of implementation. So a city, for example, can identify its own circular needs, based on its own vision and strategy. Nowadays, most cities have actually smart city strategies in general, or other urban strategies. So circularity might complement them, might augment them, might enrich those existing strategies. So cities can look at them and identify from the matrix that I have shown to you, what are some of the potentials that cities can use? What's the value for the city, and are they easy to implement or not? So based on this prioritization methodology, cities can decide what to do for their future circularity in general. So second step, the one that I have just mentioned on the left-hand side, using this simple categorization, cities can decide what to do. Then the step number 3, as I mentioned earlier, is catalyzing or boosting the circularity. If we know what we are doing in terms of these circular action items, there is a list of things that are mentioned here which will actually help the cities to implement these in a much better manner. So they can conduct awareness programs, skills programs, they can have a strategy, even a separate strategy for circularity, they can have policies, regulations, they can use procurement as a lever, as a policy lever to implement circularity. And then they can have financial incentives, public-private partnership programs, R&D programs. If they don't know exactly how to implement certain circular things, they can actually formulate research and development programs for better and effective results at the end. Certifications, SME supports, urban industrial symbiosis, especially for private sector, are all potential action items or policy levers that cities can use to boost and to catalyze circularity at the end. So that would be step number 3 for cities. And finally, we reach step number 4, where we've done all these things. We've actually catalyzed circular action items. And then we again take a stock of where we reached. What did we attain? What did we achieve in terms of our intended outcomes and impact? Did we achieve certain KPIs that we targeted? You might put targets for example, digital infrastructure sharing, for buildings recycling, for waste recycling. So all those potentials that were mentioned earlier can also be quantified with KPIs. What about the catalysis, the catalyzers or the boosting action item enablers that we used? Were they effective? Should we enhance them? Should we enrich them? And finally, what are some of the lessons we learned? So that feeds us back to, again, step number 1, again, assessing our current circularity, again, prioritizing and determining maybe new circularity action items. So that's essentially the high-level implementation framework that we developed. I'm going to mention some of the case studies. As I said, we have 8 publications and 17 global case studies as a result of our work. I'm just going to mention a couple of case studies. In Smart Dubai, for example, which is where I work at the moment, we have more than 60 plus ICT services used by more than 50 entities. So we are using digital ICT, digital infrastructure and services and sharing them across the entities. And that has allowed us to save actually more than $1 billion in 12 years. So this is circular ICT services and infrastructure, and the action item, circular action item, is sharing. Then we look at another example from India, where unused food, instead of wasting it, becomes food for the needy people, for the hungry people. So that allows us to reduce hunger in a city. The Roti Bank, the organization mentioned here in India, goes and collects actually unused food items from hotels, from restaurants, and then on the same day, literally doing the logistics, distributes it to those who are in need of food in the city. The third example mentioned is from Vienna. In this case, we have actually accommodation sharing between elderly and the young. Usually in Vienna, finding an affordable housing for the young people is not easy. So the houses are shared, the accommodations are shared by the elderly and the young people. So this is one way of sharing the household, the accommodations, but also behind the scenes, they share their knowledge and experiences as well. So this is another sharing. This is actually an example of circular society, not economy necessarily. But when we talk about sharing intangible things, our experience, knowledge between generations, then we get into circular society example. And this is a perfect example from Vienna. On the left-hand side, we have here an example from Sri Lanka, which is a wild coast tented lodge. Essentially, this is a resort that was built completely from recyclable materials, from natural materials, so they can be disassembled and used in another resort in the future or even for other purposes. Not only that, but they also recycle the used water, the water. So no water goes to waste. It's essentially recycled within the resort in general. They also collect rainwater, by the way. And also they use renewable energy. So there's a bunch of actually circularity items or actions that are taken into account in this example. Another one that's used by the same example is they have also upskilled the local population. So they only used local workers to build this resort. And those were fishermen. They were not actually, they had no idea about how to construct a lodge like this. But they were trained, upskilled, and they have literally built the entire resort from scratch, which is an example of sharing maybe skills, reusing skills, and retraining, equipping people with new skills. So it's quite an interesting circular example. The next one is the use of plastic waste in road construction. In this example, the plastic waste is collected and then processed in a machinery in a plant. And then the plastic waste is used for road construction. And the road picture that's shown here is a real example of the plastic waste being used for another purpose. The last example that I want to go through is the library of things. If you remember, I had mentioned that we have certain items in the house that we don't necessarily use all the time. The library of things essentially builds a library of all those potentially used items in a household, and they are shared in a community by different households. So there's an example from Toronto and also from London in the publications in U4SSC. So if you download those guides and the cases, you're going to see all these in a bit more detail in general. So I would like to thank you very much and conclude my presentation for Circular Cities.